Hello students, welcome to Saurabh's classes. Today we will be solving the ISI B-Stat question paper from year 2017. Today we will be solving question number 26. In question number 26 we have been said that we need to consider the function f which goes from r to r and is defined as f of x is equal to x upon e to the power x minus 1 if x is not equal to 0 and f of x is equal to 1 if x is equal to 0. Then we need to find out that which of the following statements is correct. Option 1, f is not continuous at x equal to 0. Option 2, f is continuous but not differentiable at x equal to 0. Now f is differentiable at x equal to 0 and f dash 0 is equal to minus 1 by 2. This is the option 3. Option C rather. And option 4 is, about option D is, f is differentiable at x equal to 0 and f dash 0 is equal to 1 by 2. These are the 4 options that we need to check out. So what we have been given is that f of x is equal to x upon e to the power x when x is not equal to 0 and f of x is equal to 1 when x is equal to 0. Now for continuity, what we'll do, we'll check out the value of the limit of fx as x tends to 0. So we'll find out limit f of x as x tends to 0. Now as x tends to 0, f of x will be equal to x upon e to the power x minus of 1. So this will give us 0 by, this is a 0 by 0 format. So what we'll do, we'll apply the L'Hospital rule over here and this will give us x tends to 0, 1 upon e to the power x. Now 1 upon e to the power x, this will be giving us 1 by 1, that will be equal to 1. And now this 1 is equal to f of 0. So as you can see, at x equal to 0, limit of fx as x tends to 0 is equal to f of 0. Therefore, f of x is continuous at x equal to 0. The first part of the problem is solved. So we so now next one, for differentiability. For differentiability. Now what we need to do, we need to find out basically f dash 0. So f dash 0 is equal to limit h tends to 0 f of h minus f of 0 by h. So this is equal to limit h tends to 0, f of h is equal to h upon e to the power h minus 1 by h. This is the structure that we have found out. So this will be equal to limit h tends to 0, h minus e to the power h plus 1 by h into e to the power h minus of 1. Okay, this is what we have found out. Now if we put h equal to 0 here, this will give us 0 minus 1 plus 1. Basically 0 here, 1 0 will be here in the numerator, and in the denominator also 0 into 1 minus 0, 1 minus 1, that will be equal to 0 by 0 format. So basically now we need to apply the L'Hospital rule. So on application of L'Hospital rule, we'll get that limit h tends to 0, 1 minus e to the power h, and this will be e to the power h minus 1 plus h into eh. So this will be equal to 1 minus, this will again give us 1 minus e to the power 0, this is 1 minus 1 0, and here also it will be 0 into 0, that will, it is again a 0 by 0 format, again my 0 by 0 format. So we need to apply L'Hospital rule once again. So on application of L'Hospital rule once again, this will give us limit h tends to 0 minus of eh into eh plus plus h of eh. This is what we have got, and this will give us the value, and this will give us the value minus of 1 by 2. So we have found out that fx is continuous at x equal to 0 and fx is also differentiable at x equal to 0, and f dash 0 is equal to minus of 1 by 2. So the correct option is option C, which says that f is differentiable at x equal to 0 and f dash 0 is equal to minus of 1 by 2. So option C is the correct option. So today we have solved question number 26 from the ISI B-State question paper of year 2017. We will be solving the next questions in the subsequent videos. Till then, keep watching Substance Classes videos for more solutions and content. Thank you very much.